Okay, so hello everybody, welcome to Hackschool session 7. Today we're going to be learning about life cycle. My name is Jamie, I'll be teaching the workshop today. So let's get started. So first of all, just I guess to rehash, so far we've learned all of this stuff, including asynchronous and web APIs last week. This workshop will be based pretty heavily on that, so yeah. And I guess just like a preview for the next couple weeks, we do not have Hackschool next week because it's Thanksgiving break. But week 10, we'll be having a Kahoot and pizza party. So do come out if you want to win a prize or just chill with us and eat some pizza. So with that out of the way, here's like the link to the slides in the README. I'm going to assume that you already can see them on the board. If you're not already, yeah, if you don't already have them open, I definitely recommend you at least open the README because it will be very useful. Let me just open it. Yeah, so as we go along through the workshop, you'll be able to see all the code that I'm writing, as well as look at the demos. So yeah, you should open it if you haven't already. And all right. So also, if you are a UCLA ACM member, then you can go ahead and type this attendance code, useless effect, to get the points or whatever. And also here's a link to our feedback form for this workshop. We'll link it again at the end, but please do fill it out if you're able to, because it really helps us. Okay, moving on. For this workshop, please make sure you have a text editor. Our choice is VS Code here, and Node installed. And I personally also recommend that you install React DevTools. It's just a Chrome extension. I will be using it a little bit throughout the workshop, but it will be really helpful in your React development in the future as well. Okay, and also a quick note about coding along. Please try not to like copy the code that I'm writing while I'm coding during the workshop, because it is a little hard to follow along with the content if you're trying to copy code at the same time. And there will be a lot of checkpoints where you can basically implement what I coded during the demos. So yeah, try not to code along while I'm coding. And secondly, please do ask questions if you have any. This content is not exactly the easiest, and React in general is not very easy to learn, so feel free to raise your hand at any time to ask a question or flag down a mentor who can help you as well. Okay, so we're actually going to start off with a quick checkpoint, which is to create your React workspace. So basically, you can follow these instructions to create a new React app on your computer, and then basically start the app because we will be building off of it for the rest of the workshop. I'll give like 2 or 3 minutes for this. So yeah, just go ahead and do that first, I guess. Can you raise your hand if you've like finished this checkpoint and you're ready to move on? Okay, maybe like another minute. Okay, I'm gonna go ahead and move on. If you're having any trouble running any of these commands, do raise your hand and a mentor will come assist you. So we're gonna start by recapping what we learned about last week, since this workshop is pretty heavily based off of last week's content. So if you're here last week, we learned about asynchronous programming. So essentially, throughout the workshop, we learned how to use asynchronous programming to fetch data from web APIs and also potentially displaying it in a React app. So here's just a little demo that I created based off of the content in that workshop. Essentially, I've created a React app where the user can click on this new fact button, and then the app will fetch a new cat fact from this cat fact API that I found. So yeah, let's take a look at the code for this app and just review the asynchronous programming in general. So here is basically the code for this app. You can see there's some pretty key features here. So first of all, we have this cat fact endpoint, which we're using here. We're calling fetch on the endpoint to actually get the data. We also have this use state call where we are creating this fact state variable. And if we just look where fact is used, we see that it's being displayed or being returned inside of a div, so we can display it to the user. Additionally, in the return statement, we have this button that says get new cat fact, and we have an on-click handler for this button. So every time the user clicks the button, we call get fact. And get fact is our asynchronous function, which calls the fetch endpoint, or calls fetch on the endpoint, and then after getting the data back, stores the fact in our fact state variable. So let's take a look at the actual code here, which I have in VS Code. So as you can see, I have the cat fact component here, and I'm also running the app, as you can see in the terminal. Another thing that was not in the slides is in our app component, I'm importing cat fact from the components folder and just rendering it here. So that's how we can see it. And here in this little window, I actually have the app running already. And finally, in the bottom left, I have my DevTools open. So I've opened the network tab just so we can see the actual fetch requests when I click the button. And I guess let's use the app. So I'm going to go ahead and click the button. And we see that we get a cat fact here. And also, if we take a look at our DevTools, we can see that we can actually look at the response from the API. So the response object contains this fact property, and then the value of this property is actually like the fact that we see here. So if you were wondering why I called set fact with json.fact, it's because I took a look at what the API returned, saw this fact property, and decided to get the fact out of the object. Okay, so are there any questions about any of the code that we just looked at, or how the app works, or maybe any questions about asynchronous programming before we move on? Okay, great. So in that case, we're actually going to move on to our next checkpoint. So basically, I would like you to implement basically your version of the cat fact app that I created. So you're going to create a components folder and then create a new component that will fetch data from an API of your choice when the user presses a button. If you want, you can use the cat fact API. Also, there's this numbers API, or if you have a preferred API already, you can go ahead and use that. And feel free to mock your app off of my code. I'll display it on the screen. But yeah, we'll give about 5 minutes for this. And as always, if you have any questions while you're working on this, please raise your hand and someone will come and help you. But yeah, so back to the slides. All right, so this is great and all. We have like this working app. We can fetch data from an API. It's cool and everything. But there's this like slight problem with our app, which is that we don't actually get any data when the page first loads. So you can imagine that as a user, you might want to be able to see data when you're first opening an app. For example, if you like use Instagram or Twitter or Facebook or anything, like imagine if you went to your newsfeed and you had to click a button to load any posts. It's just not a great user experience all the time. So let's see if we can fix this and have our app display data right away. So one potential solution is, what if we just call getFact once ourselves in our component to like basically get the fact at the beginning and let the user see a fact when they first open the page. So basically all I'm going to change here is just add a call to getFact right after the function definition. So let's take a look at how that works. And I just want to reiterate, in general, don't code along, but especially for this part of the workshop, do not code along, just watch. So let me go ahead and make this smaller again. And all right, so I'm going to add a call here to getFact. And let me just refresh this. Okay, and then I will save my code so the app will refresh, and let's just see what happens. Okay, so that was interesting. If you were watching, basically it started quickly going through like a million facts, and then now it just doesn't show anything at all. So why exactly is this the case? Well, if you remember back to our state workshop, React automatically re-renders components when the state changes. So basically, our app is doing something like this. So our app will first load, then we'll render our catFacts component, and then our component is calling getFact to fetch that fact for the user to see. And then getFact is going to update the state with a new fact, and then this state update is going to trigger a re-render of our component. So now our component gets rendered again, and then you can imagine this results in this endless loop. And in fact, because we're refreshing so quickly through these facts, you'll actually see in the network tab of DevTools that we start getting this like red fact. So if I click on this, we can see that our response was rate limit exceeded. So basically the API was like, you're sending me way too many requests, so I'm just not gonna give you responses anymore, which is why there's no data anymore. So yeah, this is not what we want at all for our app. So let's see, like, how can we fix this? Ideally, we would like to tell React to only fetch the catFact using the getFact function the first time that we render the component, because we know as developers that the user is going to click to refresh the fact by themselves. So we only want to manually get the fact ourselves or automatically get the fact in the app the first time the component is rendered. Okay, so are there any questions at this point about why our implementation didn't work, or like how exactly our app got broken? Okay, great. So in that case, let's move on. So before we talk about how to actually fix our app, we need to learn about a very important concept, which you may have guessed based on the title of this workshop, is about React lifecycle. So what do we mean when we say lifecycle? Well, it's kind of just like a normal, like a life cycle of a person or like a plant or really anything. And basically, there are different phases in a React component's life. There are three actually, so we'll talk about each of them. The first one is called mounting. So this is when a component is first rendered in the app. And just a quick side note about the visuals here. Something that helped me like learn this concept is to imagine like my app as like a wall. And then each component is like a decoration that you can mount onto the wall, where we're basically acting like React. So as you can see, mounting involves adding the component to the app or first rendering it. All right, so the second phase of a React component's lifecycle is updating. So whenever like a component's props or state changes, the component basically gets updated, and basically it'll get re-rendered. So for example, in this picture, maybe we change some prop to the episode to make it render as a different color. So yeah. And then the final third phase of a React component's lifecycle is the unmounting. So basically, this is when the component gets removed from the app, so kind of the opposite of the mounting part. So it's no longer being rendered in the app at all. All right, any questions about the life cycle of a React component? Okay, so in that case, with our understanding of React lifecycle, we can learn about use effect, and this is actually how we're going to fix our app. So use effect is a React hook. So it's very similarly provided by React, same as use state, which we learned about in the state workshop. And the use effect hook is pretty special because it lets us run pieces of code based on the component's phase in its lifecycle. So that's kind of a mouthful, but we will dive into it a bit. For example, we can tell React that we only want to run something when a component is mounted, and we don't want to run it ever again after that. So that might sound familiar because that's basically exactly what we want for our cat facts component. So let's take a look at what use effect syntax actually looks like. So here we can see use effect is a function, so we basically call it, and we're passing two arguments. The first one is callback. So if you aren't familiar with the term, basically when you hear callback, just think it's a function. So the first argument to use effect is a function. And the second argument, dependencies. So for dependencies, basically, if you aren't familiar with that term either, if like this thing A depends on B, then B is a dependency of A. So for an example, this is not code related, but your grade in any class that you take depends on how basically your grade for each homework or exam or assignment. So you can consider each homework grade, exam grade, assignment to be a dependency of your final grade. So yeah, just to rehash, use effect accepts two arguments. The first one is required, and it is a callback function containing the code that we want to run. And the second is sort of optional. We'll get into this basically next. And it's an array of dependencies. And the dependencies array is basically used to tell React when we want to run the callback. Okay, so let's talk a little more about the dependencies. Basically, we can pass in, or I guess we can consider three different cases for the use effect dependencies. So first of all, we can simply not pass it in at all. So I can call use effect with just the callback function and no second argument. And what this means is that the callback will be run every single time the component gets rendered. So when the component first mounts, the callback will be called, and then every time the component gets re-rendered, we'll call it again. A second option is to pass in an empty list for the dependencies. So I can call useEffect with some sort of callback and then just this empty list. And if this is the dependency list, then React will only run this callback when the component first mounts, and then it won't run it ever again. And then finally, we can actually have a non-empty list. So if we pass in a non-empty list, then the callback will be run every single time the value of any dependency changes. So in this little code snippet, I'm calling useEffect with the callback and an array consisting of A, B, and C, where A, B, and C are some variables that I've probably defined earlier in the component. And basically, anytime the value of A, B, or C changes, the callback will be run again. Okay, dependencies are a little confusing, so are there any questions about anything to do with useEffect or the dependencies list or callbacks? Okay, if there's no questions, then let's take a look at how to apply this to our cat facts app. So here I have a code snippet where I've actually added useEffect to my code. Let's just break it down into each piece. So first of all, I need to import useEffect the same way as we import useState or React from the React library. So we're importing useEffect. The second change I've made is basically adding this useEffect call. And for the first argument here, you see I'm passing an arrow function. So we have these parentheses, arrow, and then these braces. And inside of the callback, we're simply calling getFact. So basically I'm saying to React, I just want you to call getFact based on the dependencies list. And then finally, for the dependencies list itself, we're passing in an empty array because, like I said earlier, we want to tell React to run this code only when the component first mounts, because every time after that, we want the user to click the button and get the fact themselves. So since we only want to run this getFact automatically the first time we mount the component, we're passing in an empty list here. Okay, so now let's go ahead and actually change the code. So first things first, I'm going to import useEffect at the beginning of my file, and then I'm going to actually call useEffect. So after we've defined getFact here, let me type useEffect, and inside of this, I'm going to pass 2 arguments. So the first argument is a function. So as usual, I'll use this arrow function syntax. And then inside of the body of our function, I'm going to call getFact. And then secondly, I need to pass another argument to useEffect. So I'll add a comma, and then I'm going to pass in this empty array for the dependencies list. So I'll go ahead and save my code. And then since I paused the app earlier, I will run npm start to run it again. And now you can see it's loaded. And indeed, when we first rendered the app, there was a fact already here. You also might, or I guess it loaded really fast this time, but if the cat facts API took a while to give us a response, then at the beginning we would see generate a new cat fact for this text, which is not entirely accurate. So I'm going to replace this with loading. In the case that the cat facts API is slow, the user will see the loading text here, and then that is an indication that some data is loading. Okay, great. So for the next checkpoint, basically I want you to integrate useEffect in your app. So import the useEffect hook in your component, and then call useEffect to fetch data from the API when the component first mounts. So I'll give a couple minutes for that, and I will leave my code up here so you can see. And yeah, let's take a few minutes for that. Okay, so basically we've kind of learned basically everything there is to know about useEffect, more or less, or at least everything we're going to be covering for this workshop. So for the rest of the workshop, we're actually going to be making like a more advanced app using, I guess, the dependencies list for useEffect and not just passing in an empty list. And also, along the way, we're going to learn some other neat JavaScript and React things that will hopefully allow you to develop more interesting and interactive apps. So I'm actually just going to start coding, I think. Yeah. So basically, to start, I'm going to create a new component that we'll be working off of for the rest of the workshop, because this cat facts one is cool and everything, but if we want to have like interactivity, we needed something a little more interesting. So I'm going to go ahead and create a component called componentinfo.js. And I guess just to preface, I'm going to be using a new API that we haven't looked at yet. Let me see if I have a slide. Okay, I don't. But essentially, I'm going to be using this Pokemon API. And the reason for this is because you can actually specify different things as the input and get different data based on what you input. So yeah, so this is basically going to be the API I'm using. And you can, I guess, yeah, let's just get started. So as always, when I'm creating a React component, I'm going to start by importing React. And then declare my component. So I'm going to say function Pokemon info, and then at the end of the file, I'm going to make sure to say export default Pokemon info. So there's kind of the skeleton of our component, and I'm also going to change app.js to import this new component. So I'm going to import Pokemon info from, just a reminder for paths, because we are currently in the source folder and we want to access something in the components folder. I will say // to say starting from this folder, then go to the components folder, and then import it from Pokemon info. Okay. And then instead of rendering a cat fact here, I'm going to render Pokemon info, just so we can watch the app update as we save. And then I'll go ahead and comment this out. So yes, our component is currently empty, but let's add some stuff. So basically, like the cat fact component, I'm kind of just going to mimic exactly what I did for cat fact, but using this new endpoint instead. So to start, I'm also going to just use a specific Pokemon because we don't yet know how to accept user inputs. So let me declare okay, let me declare an endpoint here. So I'll say const Pokemon endpoint equals, and then we have this pokeapi.co/api/v2, and I'll just use Pokemon Eevee for this demonstration. So now we have our Pokemon endpoints, and then now let's create a state where we're actually going to store the data that we get from the Pokemon endpoint. So I'll say const data and set data equals use state, and let's just leave it empty for now. And because we are using use state, we also have to import it at the top from React. So I'll go ahead and add that. Great. So now, basically, we're going to create our asynchronous function that will actually fetch the data from the endpoint. So let's declare a function. I'll call it const fetch data equals async. And then inside the body of this function, I will get a response. So I'll say const response equals fetch Pokemon endpoint. And I forgot to await. So let's say await fetch Pokemon endpoint. And then next, let's say const response JSON equals await response.json. So here we're getting the initial response from the Pokemon endpoint fetch call. Then here we're actually going to get the data returned in the response in a JSON format. And then finally, I'm going to set the data equal to our response JSON. So here's our fetch data function. And now let's actually return something to the app, or return something in our component so we can see something in our app. So I will return inside of a div, let's have an h3 that says information about Eevee, because that is a Pokemon I picked. And then inside of another div, we can say data. But because I actually know already from looking at this Pokemon API documentation that Eevee is, or the data that we get is going to be this like ginormous object, what I'm going to do is say json.stringify data. And basically this is something provided by JavaScript. So if you say json.stringify and then a JavaScript object, it will essentially convert that object into a string representation of the object, and that way we can just display it in the user interface. So let me save. And then as you can see, we just see information about Eevee and there's no data here because we never actually called fetch data. So let's use the, I guess, trick that we learned earlier in this workshop and use useEffect to get the data once at the beginning. So I'm going to import useEffect in the top of the file and then call useEffect here. And recall that the first argument of useEffect is a callback. So inside of the body of this function that I'm creating, I will call fetch data. And then we'll have to pass in a second argument after our callback, which is the dependency list. And since I want this to behave basically like cat fact for now, I'm going to pass in an empty dependency list. So now when I save, we actually see that the component goes ahead and fetches data once. And now we get this ginormous object in a string format in our app. So this is where I will stop for now. And we're going to have another checkpoint where you basically do the same thing that I just did. So first, look for some cool API that you like that lets you actually pass information in. So for example, you could use the Pokemon API that I just used. I also found these other two. You don't have to use any of these, but just if you don't know what else to use, there's this Ageify API and this Board API that basically lets you pass in data and then gives you a response based on the data. So first, pick an API, and then second, create a new component, basically like the cat facts one or like the Pokemon info one I just created, um, that fetches data from your API. And since we don't yet know how to get user inputs, you can go ahead and just hard code the value that eventually will have being passed from the user, and then display the data in your app. So um, let's give like 10 or 15 minutes for this. I'll leave my code up here, and yeah, so go ahead and get started on that. Okay, so so next what we want to do is make our app actually interactive, and to do that, we're going to have users input basically being used in our app. So we're going to basically learn how to create forms in React. So all the way back in session 1 of Hackschool, we learned briefly about the input tag and the form tag, and now we're going to learn how to use them in React. So actually, let's just take a look at this code snippet that I have here. Sorry, one second. Okay, so I've pretty much implemented here a form component, and let's just kind of break it down into different pieces because this is kind of a lot. So first of all, this like return should look more or less familiar. We have this form tag wrapping these two input tags. So basically like HTML. And if we look at our input tags, the first one has type equal to text. So this will actually render a field where users can type, like this text box here that we see. And for the second input type, we have submit, which actually will create the submit button. And when this button is clicked, we will submit the form. Okay, so next we have some React stuff integrated in our form here. So first of all, we see that we have this state variable, user input, that is being passed to this input as a prop called value. So the value prop for the input actually specifies the value that appears in the text box here. So you can see that our state is basically tied to this input tag. Another thing that we see is that we have these event handlers. So we have this first one on the form tag called onSubmit. And basically when the form gets submitted, this onSubmit event will trigger and we have to handle it here. And then the second event handler we have is this onChange event handler in the input tag. So yeah, let's take a brief, I guess, look at that. So you also might be a little confused because there's some strange stuff here that might not look very familiar. So first of all, this e.prevent default thing that we have inside of our handle submit function. So handle submit here is our event handler for the onSubmit event. And E here is basically the event, which is like the submission event. And you might be wondering, why do we have this e.prevent default thing? So essentially, because of the way HTML forms work, when you submit a form in HTML, it will basically refresh the entire page. So in our React app, it will refresh the page and basically re-render the component, and we like lose all the state that we might have saved already. So we want to have this e.prevent default to prevent this default HTML form behavior and not refresh the page. The second weird looking thing is this e.target.value inside of our onChange handler. So let's break it down a bit. E in this case is the event, the like the changing event, and an event is an object in JavaScript. And one property of the event object is target, and the target property is basically the element that triggered the event. So in this case, it will be the input tag that we specified here. And finally, we have this dot value part. So the dot value part, again, the target is another object, and inside the target object, there's a value property. And if we get the value property, we can actually see what the user typed or changed about the input. Okay, so now I will go ahead and demo how we're going to integrate a React form in our app. So the basic idea here is that in our app.js file, we are going to create this form, and we're going to keep a state to keep track of what the user typed and submit it or like pass it to the Pokemon info component as a prop. And that way we can use that prop to call our fetch or to fetch our endpoint with the user's input. So before I actually get into implementing the form, I'm going to modify this Pokemon info component to accept a prop. So let's go ahead and say props, and let me remove the hard-coded Pokemon name here from the URL. And now let's basically use this prop throughout our component. So first of all, our fetch data function should be changed to also accept a Pokemon name. So I'll just go ahead and say Pokemon name. And now when we actually fetch the endpoint, we don't want to just fetch Pokemon or like API/v2/Pokemon. We also want to use the Pokemon name. So because these are both strings, I'm going to concatenate them together or put them together using the plus. So I will add the Pokemon endpoint to the Pokemon name. Okay, great. So now our function, our handler, our asynchronous function can accept the Pokemon name and then fetch data using the Pokemon name. But we're still missing some key parts here. For example, we never actually pass the Pokemon name to fetch data. So let's go ahead and do that. I'm going to name this prop Pokemon. So I'll say props.pokemon to actually call fetch data. And then now we can actually see there's this squiggly line here. React hook use effect has a missing dependency, props.pokemon, which is very helpful of VS Code to tell us. And let's go ahead and add that to the dependency list. So this way, whenever we change the prop Pokemon, we'll call use effect to fetch the data. And now, just to make our app more accurate, let's change this information about Eevee to say information about props.pokemon. So essentially, now our Pokemon endpoint is more generic. We don't have a Pokemon name here. We have props for our Pokemon info component, and when the Pokemon prop changes, we will call fetch data, passing the Pokemon into the fetch data function. And so hopefully this will work. But before that, we need to actually implement the form where the user can submit. You'll see that actually when I saved, we get some data here because this endpoint without the Pokemon name actually already returns data, but let's just ignore that for now because we want specific Pokemon information. So in our app function, let's implement a form. So to start, I'm going to have basically what we saw in the slides earlier. So I'm going to create a state for the user input that will pass into our form later. So const user input set user input equals use state, and we can just set it to the empty string. And then let's remember to actually import use state from React. Okay. So now we have a state, and let's create a form inside of our app. So I'll start by adding a form tag. And then inside the form tag, let's have some inputs. So my first input is going to be type equals text. And this is where the user can actually type. And basically just like the example in the slides, we're going to pass the value as user input. And whenever this input changes, we're going to call set user input. So on change, let's call set user input with e.target.value. Okay. And then secondly, let's make our submit input so that we get a button to submit. So I'm going to say input type equals submit, and this will give us a button. Okay, awesome. There's still a few pieces missing. So for example, we don't have the form on submit handler. So let's define a function first that we'll use for submitting the form. So I'll call this const handle submit equals e for the event, and then let's start with prevent default. Okay, And then now we can go ahead and add this on submit handler to our form. So on submit, we want to call handle submit. All right, so this is great and all, and we basically copied over the code that was in the slides. But we're actually still missing something outside of the fact that we're not actually doing anything in handle submit, which is a second state. And I'll explain why later, but let's just go ahead and create a second state to store the Pokemon. So I'm going to say Pokemon set Pokemon equals use state. And I guess I can just explain essentially why we need two states. So imagine if in Pokemon info, I said Pokemon equals user input, okay? So we're just using the state that we used, that we got from the input tag, and we're just going to pass it to Pokemon info. Well, if we think about this, in our Pokemon info component, we have this use effect where every time props.pokemon changes, we're going to call use effect. And we also know from our input tag that every time we type something or change something, we're going to set the user input. So the user input will change every time we type something. And because of that, we can basically just see it in action here. If I type something, oh, actually, I guess it's, okay, yeah. If we look at the network request, I guess, you can see that every time I type, we're making a new request in the network tab. So the reason for this is because we're typing a new character, so then set user input sets the user input to something else, and then Pokemon info, the use effect here, detects that props.pokemon has changed and then fetches data again. And this isn't exactly great behavior because like we know that the user's not going to be able to just type the entire Pokemon name in one go. And we only actually want to try and fetch the Pokemon when they're ready to submit it. So that's why we have a second state here. So instead of passing user input as the Pokemon prop, let's pass Pokemon. And the way we're going to make sure that Pokemon gets set every time the user submits is in our handle submit function. So let's add a line in handle submit. So when the user submits, let's set Pokemon equal to whatever the user input currently is. Okay, and then I guess we can just save this. And now let's see what happens. So if I start typing ABC, we can see that we don't get those like requests for every single time I type. Like earlier we said A, AB, ABC, and none of those worked. But now we are not actually calling anything until I say submit. And then now we can see that I made a request for ABC and it wasn't found. But let's go ahead and use an actual Pokemon. So for example, we can do Eevee, and we see information about Eevee, and we actually get the whole object. So I think, yeah, I think that's, yeah, so that brings us to our next checkpoint. Basically, implement the functionality that I just did. So change your component to actually use a prop to fetch the data. So instead of hard coding a value to fetch from, you can accept a user input instead as a prop. Then create a form inside your app component that actually accepts the user input and passes it as a prop to the component. I guess we can give 10 or so minutes for this. Let me, yeah, that's good. Let me share my code here. And I guess before everyone gets started on that, are there any questions about any of the changes I made, or why we need two states, or just how forms work in general? Okay. In that case, yeah, let's take 10 or so minutes to implement this, and then we can move on. Okay. So, all right, now we have like this cool interactive app that users can submit data, and then we can use that data to fetch stuff from the API. But there's still like a few issues or just like improvements we can make for the app. For example, like now we're back to the same problem where we don't have data in the UI when it first loads. We also haven't really handled any errors that get returned by the API. And finally, like our data doesn't look that great. Like we're basically just printing this huge JSON that is like, you know, if this wasn't my website, I probably wouldn't use it, right? So let's just see how we can fix some of these issues. The first problem is that we don't have any data before the user submits an input. So one thing we could do is change our form, like change our app so that our Pokemon is initialized to be some value, which would work fine. But because I wanted to teach some other topic, we're going to learn about object destructuring instead. So basically, when we learned about useState, we saw that we can destructure arrays into their elements. So useState returns an array of 2 elements, and we can actually name these elements user input and set user input. So similarly, we can actually destructure objects in JavaScript, and that includes props because props is just an object. So for example, if I was making some sort of version of Netflix and I had this function component, instead of just saying props.title, props.description, like we see here, I can actually destructure these props at the beginning and say that I have title and description inside of the props. And now for the rest of my component, I can just say title and description instead of props.title and props.description. And you might be wondering, like, why is this useful? Like, why should I care? Literally, it just seems like we're just adding an extra line for not a ton of benefit. Well, one nice thing is actually, like, you can avoid typing props dot whatever over and over again. Like, it just makes things more convenient. Also, if you destructure all of your props at the beginning of the component, then that really helps you like know what props you have available in the component without having to constantly refer back to like the parent component or like scroll back up and see what props you've already used. So especially when your components become larger and more complex and you have more and more components, it is like nice to destructure them so that you know by like at the end of your function what props you had throughout. And one more thing is that when you destructure an object, you can also specify a default value for each item inside the object. So if the property doesn't exist in the object, then we can actually like create the property ourselves. For example, in this case here, I have this episode component again, and I'm just going to say that if title isn't provided in my props, I'm going to set it to aperitif. And this can be really useful because before I move on, like talk about that, we can also do the destructuring directly in the arguments. So we don't even actually need to say props at all. We can just directly say that the episode will get this props object without saying props, and inside should be a title and a description. So what this will look like in practice is in our Pokemon info component, instead of saying props here, I can say that we will get an object, and inside the object is going to be a Pokemon. And here I can actually specify that the Pokemon, if not provided, should just be Eevee. And now that I've destructured my props, I can remove everywhere that I said props.pokemon to just say Pokemon, which in my opinion looks cleaner. And of course, it's a style choice at the end of the day, but yeah, I prefer it like this. Okay, so that's nice and all. And that kind of solves our first problem of not having data in the beginning, because if we provide a default prop to our component, we can just fetch the data using that prop. Okay. Now, the next issue is that we don't handle errors. And what do I mean by this? Well, if I type some Pokemon name that doesn't exist, like ABCDE, we'll see that in the network tab of our dev tools, this request failed because there's no Pokemon named ABCDE. However, we still say in our app like information about ABCDE, and then we still show this old data about Eevee, which is not accurate anymore. So basically, we would like some way to detect if an error occurred during this fetch, and then maybe display something more useful to our users. So one option for this is to use a try-catch block. So what we'll do is wrap our fetch call with a try-catch block. And what exactly is a try-catch block? Essentially, it looks like this. So we have this try and then the braces and then catch, error. It doesn't have to say error. You can say E or error, or yeah, you can name this whatever you want. But essentially that is the error that you are catching. And then inside of the try block, we put the code that we want to run but could potentially produce errors. And then inside of this catch block, we can actually handle the error. So for example, if I were to implement this in my code, it would probably look something like this. So our fetch data function, the const response equals await and the response JSON equals await is what can actually cause the error, right? So what I'm going to do is wrap this in a try catch. So the try code or the try block will contain the actual fetching, and if I manage to get the response and the response JSON without any errors, then what I'm going to do is call set error message to this empty string, which is this new state that I've added here just to keep track of if there's an error. And then we can set data to the response JSON as always. However, if an error does occur at some point in this try block, then we can catch it. And if we do find an error, then what I'm going to do is set the data to be nothing, so that way we're not showing incorrect data anymore. And I'm also going to set an error message. Sorry, we couldn't find any info about the Pokemon name. So let's just try this out and see how it works. So in my fetch data, I'm going to add this try block, and I'm just going to copy everything in here inside the try block. I'm also going to add a new state for the error message. So error message, set error message equals use state, and let's just have it be the empty string. So if this, if all of this code succeeds, then we can set the error message to be empty. So that way, if there was an error message to begin with, we'll clear it out and not show an error message anymore. And then I'll add this catch block, and inside the catch, I know something went wrong. So what I'm going to do is set the data to be nothing so that we aren't showing the stale data anymore. And then I'm going to set the error message. I'll just say I could not find that Pokemon. Okay, and finally, now that we have this error message thing, I'm going to actually return it at some point. So let's just have a tag inside of which we can render our error message. All right, so now if I save, let's clear this out. Okay, so we have information about Eevee, and if I type ABCDE, now it says I could not find that Pokemon. I mean, it still says information about ABCDE, but at least it doesn't show information anymore. Instead of doing a try catch block, you can also check the response status. So if we go look at our network tab really quick, we can see that every request has the status to tell us if it succeeded or failed. And actually, the HTTP request, you don't really have to worry about this number because there's this other property inside the HTTP response called OK. So this is true if the request was successful and false if there was an error. So basically what we can do is, like always, get our response, say response equals await fetch, and then we can actually just check if response.ok is true, then we can do all this stuff assuming that the data was good. Otherwise, we can basically do the same code that we did in our catch block to set the error message. I guess I already demoed the error handling, so we can, oh, okay, I guess there's this last checkpoint, but before we get to that, I just wanted to demo something, which is back to like the appearance of our data, basically. This is not exactly nice to look at as a user. So what exactly can we do to make this better? Well, we've learned like some JavaScript features earlier, like map, and I'm actually going to use map to create some elements that we're going to render instead of just this JSON. So if I look at the format of my data by looking at this network request, in the object itself, we see we get this abilities array. And inside this abilities array is a bunch of ability objects. And the ability objects each have basically an ability property, which is another object inside of which there's a name. So what I'm going to do is convert this abilities array into an actual like HTML list. So here's what I'm going to do. I'll create a variable called abilities list, which will eventually store my HTML list. And then what I'm going to do is check if data is populated. So let's just say if data, so if data and if data has an abilities list. So if data and data.abilities list, what I'm going to do is say abilities list is equal to data.abilities. Oh, wait, sorry. This should just be abilities. My bad. So abilities list is equal to data.abilities, and then we're going to use map. So if you don't remember, map basically takes an array or a list, and for each item in the list, you can define a function to convert it to something else. So I'm going to map each ability. I'll just call it A to return a list item, and inside the list item, what I want is, let's see, so A is basically like this object 0, for example. So inside of this object, there's a property called ability. So I'm going to say a.ability, and then inside that is a name. So I'm going to say a.ability.name. And we'll return basically a list item with the ability's name. So now my abilities list should theoretically be an array of list items. So I can add this part in my code to have an unordered list, inside of which I'm simply going to render the abilities list. Okay, so that was kind of a lot, but basically, if we get some proper data and the data has this abilities property inside of it, what I'm going to do is take each single ability inside of this abilities list and return a list item. And then later on, I'm going to render this list of list items inside of an unordered list. So if I save, I should remove this part because it's really long. Then we can see we actually get this unordered list of abilities. And I guess I can just say something like the Pokemon, or rather, let's say Pokemon has the following abilities. So now we've basically learned how to parse the data from our data object into some sort of like better looking-ish way of displaying the data to the users. Obviously, you can get more creative with this, and instead of just showing the abilities, you can get like a whole bunch of different information and render it to the user. So that's actually the final checkpoint, which is to add a default value to your component's props so that you get some data when the app first loads. Then also add some error handling. So if the user types something that results in an error, we can somehow show the user that an error occurred. And finally, try and get creative with how you display your data. You can try like doing what I did, so mapping a list of objects to components, or you can experiment with some CSS properties and styling. Honestly, like at this point, the world is kind of your oyster. Like you can, just do like whatever you want. So that is the last checkpoint for this workshop. And we're actually a little over time, so I'm gonna like finish the slides, and then if you want to work on the workshop or want to work on your project, you can go ahead and do that. So this is just like a little announcement, especially if you weren't here at the beginning to hear it. So there's no workshop next week, but during week 10, there will be a Kahoot session and pizza party. So if you participate in the Kahoot, you have a chance to win some prizes. And also, if you plan on going, please RSVP ahead of time so we can get a head count for how many people will be there to eat pizza. Other than that, thank you for coming. If you get the opportunity, please do fill out our feedback form. And yeah, I guess look out for the RSVP form for the Kahoot thing in 2 weeks. But yeah, that is it for this workshop. Thanks for coming again.